Yesterday, we took a look at inverse variations. Today, we're going to take a look at what their graphs look like. So, the graphs of inverse variations have two parts. Each part is called a branch. So I'm going to go through and I'm going to use Desmos very similarly to how I did a few days ago when we were doing the square root functions. I'm going to go through and describe our transformations using Desmos so we have a visual way of what it looks like. So we're going to be taking our most basic inverse variation function. I'm going to move it left, right, up, down, or reflect it over the x-axis. And we'll talk about the positioning of the number and what effect that has on the graph. So in Desmos, I've already typed this first one in. So I'm going to leave this part here so you know what I'm typing in. So I already typed in f of x equals 1 divided by x. This is our parent function. So this is our most basic inverse variation function. It's the one that starts everything else off. From this particular function, I can move it left, right, up, down by however many spaces, and I can reflect it across the x-axis. So if I do a rough little sketch, of course, it's going to be way prettier in Desmos, but a rough little sketch would look something like this. So these are called branches, and this is my most basic inverse variation function. All right, let me slide over and let's take a look at B. This time I'm going to be graphing f of x equals -6 divided by x. So let me get rid of this one. So this is what this one looks like. So a rough little sketch. I got one branch in the second quadrant, and then I have another branch down here in the fourth quadrant. So I'd already previously typed that into Desmos. Two more that we'll take a look at. I also typed in 1 divided by x plus 2 into Desmos. This function looks like this. I got a branch up here, and then I have a branch that comes right here. So right now, you should just be writing your equations down and sketching them on a paper, and we're going to go back in just a minute and talk about our transformations. And the last one, let's see what the last one looks like. It's this purple one that's here. Goes there, and then it comes over here. All right, so let me get rid of this. Let me put my parent function back up here for just a minute, and let me go back to our notes paper and let's talk about a few things. So far all I've done was sketch each of these 4 graphs on a piece of paper. Well, I did it in Desmos and then sketch it on a piece of paper. In an inverse variation function, f of x equals k divided by x. When k is positive, the branches are in the first and third quadrants. If k is negative, the branches are in the second and fourth quadrant. K is our constant of variation. It's the number in the numerator. Okay. And let's come down here and fill some of these out. The graph of f of x equals k divided by x plus c is a translation of our parent graph. If c is positive, the graph moves up. If c is negative, the graph moves down. The graph of f of x equals k divided by x plus b is a translation as well. A slide of our parent function. If b is positive, the graph moves left. If b is negative, the graph moves right. So let me put this in some simpler terms. So we're having inverse variation. It's set up in fraction form. It's got a top and a bottom, a numerator, denominator. If you put a number on the outside, if that number is positive, it's going to move it up. If this number was negative, it's going to move it down. If you put a number in the denominator, in the bottom of our fraction, if that number is positive, it's going to move left. If that number is negative, it's going to move right. Up here is telling us which way my branches are going to go. So if I look at my graphs, if my number is positive, it's going to be in the first and third quadrant, like example A. If my number is negative, it's going to be in the second and fourth quadrant. I also want to compare all 4 of these together based off of my parent graph. So this is my parent graph, 1 divided by x. That's the most basic one. two things happen with this -6, and two things happen with this negative and with the +6 here. The negative on the outside reflected it over the x-axis. So this negative in front of any kind of function is going to reflect over x-axis. And as we wrote down here, it also moved my branches. So moved the branches. So I'm basing all of this off of my parent function. That's going to be our go-to. That's where we're starting from. So this is the most basic one. That's where you're basing everything off of. This one down here at the bottom, if I compare this to my parent function, it moved up 2 spaces. So this one is up 2. This one, again, I'm going back to basing it off of my parent function. This function actually moved left 2 spaces. So the number on the outside is going to move it up or down. The number on the in the denominator is going to move it left or right. And if you have a negative, it's going to reflect over the x-axis. So let's see if we are able to come up with our own. The graph of f of x equals 1 divided by x is translated 5 units to the right and 3 units down. So let's start with the 5 units to the right. That means I'm going to be adding something in the denominator. So that's what this section down here says. And since I'm moving it to the right, that means that my number needs to be negative. So this is going to be 1 divided by x minus 5. I also want to move it 3 units down. That's going to be the number on the outside of the fraction. So minus 3. For B, the graph of f of x equals 2 over x is reflected over the x-axis and translated up 2 units. So a reflection over the x-axis means I need to add a negative in front of my whole function. And if I'm moving it up 2, that means I need to add something on the outside of my fraction, up 2. And last but not least, the graph of f of x is equal to 4 over x reflected over the x-axis, translated down 3, and left 1. So this is going to look like, let's take one piece at a time, reflected over the x-axis. So I'm going to have a negative in front of the whole thing. Translated down 3, that means I need something added on the outside. And if I go left 1, if I refer back up here to my notes, it moves left, that number needs to be positive. So it's actually going to be a positive 1. All right, so this is what our inverse variation functions look like. Feel free to use Desmos. I still have Desmos in here. You'll be able to see what happens. So from this function to the second one, notice it reflects over the x-axis. That's what the negative does. From the red function to this green that just popped up, the whole function moved up 2 spaces. And one more thing to take a look at from my parent function down here, notice to the purple. So from the red to the purple, it moved left 2 spaces. So Desmos is a good place for you to look as well. Type in your parent function and see what reflections come up.